All right, kiddies, let's take a look at your answers to the analysis questions. Hopefully you have a couple of graphs that look a little bit like this. At least this is what my graphs end up looking like. So hopefully we can use those to help us here. So when comparing our two graphs, to get this first point, each of these questions is going to be worth 1 point. You need to have both of these. I guess you could take a half point off if you had one of these wrongs. But as far as similarities go, there are many things you could have said. You could have said they're both line graphs. You could have said they both have the same unit on the y-axis. You could have said they're both having to deal with gravity as far as the rings of Jupiter or Saturn are concerned. Anything like that's fine for similarities. But for differences, there's one major difference. This is a linear graph when it comes to mass, but when it comes to distance, you have a non-linear graph, or you could say it's curved versus a straight line. That's a huge difference that's going to come to play here in a little bit. So if you didn't have that for your differences, please mark it wrong. At least a half point off this first question, since again, each question is worth 1 point. Analysis question 2 says, if you look at these two planets below, if their diameter is the same, but planet B has twice as much mass, which one would you expect to have stronger gravity? Well, of course, it's going to be planet B, but you need to say why to get full credit here. And it's going to be planet B because it has more mass, right? That's simply what you need to have. More mass equals more gravity. Pretty easy. Question 3 then gets into the other thing we know about gravity, is that distance is important. The closer you are, the more gravity you're going to have. So when it asks which astronaut's going to feel the pull of the planet more, astronaut B is. Why? Because he's closer or has a shorter distance. Something to that effect. You need to have both person B and Y to get that point correct. Question 4. Your friend tells you that if you double the distance of a spacecraft from a planet, the gravitational force is half as strong. Is he correct? And then you have to give some evidence. And the answer is no, that person is not correct. And the reason being is because it's not this kind of a graph, it's this kind of a graph, right? So when you look at the curved graph, let's say at 100,000 kilometers, it's at 40,000, I guess, or actually 400,000 newtons of force, right? The point being is, you would expect then when we went to 200, you'd have half of that. But no, when we go to all the way to 200, we only have 10. We would expect 20. That's because, again, it's not a linear number. So no, this person is not correct. You cannot simply cut it in half because this is a non-linear graph. And finally, if Jupiter is a whole lot further away from the sun than Earth, but its gravitational force is greater than that of the Earth and the sun, then what must be the case with Jupiter? So even though it's a greater distance, it can have a stronger gravitational force if it has a whole lot more mass, right? So to get this point correct, you had to say that Jupiter has a lot more mass than Earth. Cool? Great. Go ahead and give yourself a score over 5 on your paper, and we'll go record those to the side in just a moment.